All right, guys, this is day 2 or day 3. It's getting ready for the quiz, but it's also some stuff on vectors. So this particular problem that I finished going over was on page 489. Is that right? Number 37, 48, 489, somewhere in there, number 37. So you can see it. I went over it already, so you can't hear me do it. Sorry. Emma. 469 is the parametrics assignment. Okay. This is a tricky question, trickier than anything on the quiz. Okay. This is 469, number 40. This is the parametrics. This is tricky for 2 reasons. Okay. You have to do a question like this on the quiz, except it's not tricky like this. This one is tricky because it's in meters per second, not feet per second. So you had to use this instead of the minus 16 that we normally use when it's feet per second. The other trick was they're really cruel and said hit the ball 55 centimeters above the ground, and this is in meters per second. So back here, which I need to slide this over, back here at the back of the problem, it should be a 0.55 because it's 55 centimeters and everything else in the question is meters. All right, so we looked at the pink sheet and it said to do this in parametrics, you do t times the initial velocity times the cosine of the angle. Everybody okay with where I got all those numbers? This one is y equals t times the sine of the, times the initial velocity times the sine of the angle. And then it's usually minus 16t squared, but because this one's in meters, we do minus 4.9 t squared, and I promise on the quiz it's feet. And then it says plus initial height. Well, initial height was 55 centimeters, which is 0.55 meters. All right, so then we go to our calculator. We are going to have to put it in parametric mode, and we're going to have to pick an appropriate window here. But in parametrics, 18 cosine of 15. Some of you aren't getting much out of this. If it's because you already have it done, that's great. It's because you're taking a little snooze, not so much. Okay. Window. I don't think it's to take more than 5 seconds for the tennis ball to come down, probably more like 3. Maybe I'll put 0 to 4. Anyway, but t-step 0.1 is appropriate. How far away? Do we have any hints about this? The net's 1.5 meters tall, 10 meters from the net. I don't think it's going to go very far. 25 meters? I don't know. And height? I don't think 10 meters. That'd be 30 feet in the air. Yeah, pretty sure that's a ridiculous window, but okay. So my window's not bad, except my 10 meters at the end could have been easily 5. All right, so let me write down what I did. I think I did 0 to 4 by 0.1 for t. Does anybody remember what I did? 0 to 5, 0 to 20. Is that all I did? 25? Okay. Something like that. Yeah. All right, for x and y. All right, now let's see what we got to answer here. A says use a graph. Yeah, we graphed it. Okay, B, how long does the ball stay in the air before hitting the ground? What do we want to do? Katie, are you stuck? Okay. We want to find t, but what do we have to adjust to? When it hits the ground, y has to be 0. The height has to be 0. Okay, so it hits the ground between 1 and 1.1 seconds, yes? Somewhere between 1 and 1.1 seconds. And I'm fine with that answer. You can say 1 or 1.1 seconds and I'm good. can say 1, I don't care. If Jill is 10 meters from the net and the net is 1.5 meters above the ground, will the ball clear the net? Okay, so it's got to go 10 meters, and then we find out what the height is. Okay, so how do we go 10 meters away from us? X has to be 10. So let's fiddle around till X is 10. Around there somewhere. It's close. But does she clear 1.5? Yes. Barely, but yes. It's a good shot. Just clears the net, right? If so, by how many meters? Okay, well, now they're really just getting picky. What did you get it to do? If you did 0.55, was it better? 0.58 is, I'm just trying to get as close to 10 as I can. So it looks like to me like 0.1 of a meter, like 10 centimeters it clears by. At 10, when X is 10, Y is 1.6, so it clears about 0.1 meter by about 0.1 meter or 10 centimeters. Yes. No, they're on the back of the pink sheet. But on the back of the pink sheet, I said it was okay to take out the 1/2 G and just write 16. Did everybody do that on their pink sheet? You know what I'm talking about? Then I want you to open it up and go tomorrow. What's 1/2 G? We just used minus 16. Everybody good? All right. What else? You want me to go over some stuff on the green sheet? Do you want me to go over stuff on worksheet 2? Yes. Page 488. Do I have that open? I think it's this one. Number which one? Okay. The direction of the resultant is 31 degrees and the horizontal component of the force is 86 newtons. Ooh, interesting. Okay. So pulling a sled 31 degrees is the resultant here. But we don't know how long that is or the force there. We know this force down here is 86. Okay. So I'm going to call this R for a minute because I'm thinking, what? Oh, yeah, we could just do right triangle trig, but I'm thinking that R times the cosine of 31 is what gave us 86. We want to just go backwards. Yes, we could, I think, find the hypotenuse when you know the adjacent. So you could have done 86 divided by the tangent of 31. That can't be the same. Tangent is adjacent. Yeah, that's what we're doing anyway. Yeah, if you had set it up, the cosine of 31 equals adjacent over hypotenuse, it's exactly the same thing. Which is, I didn't type it right, so did anybody get an answer? 1.3. Someone else get that? Okay. That's the magnitude of the resultant. We actually did this first. Okay. But how do we find this side then? The vertical component. Yeah, you could do tangent with the 86, or you could do Pythagorean theorem, or you could do 31 sine of 100.3. Any one of those would work. 29.5-ish. Anyone get that? Whichever way they did it? Or not? I probably typed something wrong. Yeah, I totally typed something wrong. It should be 100.3 times the sine of 31. I think I said it wrong too. 51.7? Yes, no matter which way you did it, you should have got 51.7. Don't listen to me. All right, that was a good question. Kind of helps us do some things backwards, but there's not one just like that on the quiz. All right, I am going to, where am I going now? Worksheet 2? Worksheet 2, number. We can go back and do 3. Number 5 for sure is a good question. Actually, can I do 3 first? And then I'll do 5, I promise, okay? Number 3 says, Caroline walks 45 degrees north of west for 1,000 feet and then 200 feet due north to the grocery store, go grocery shopping. How far and at what north of west quadrant bearing is she from her apartment? Okay, we can do this by saying she went 1,000 feet at a 45-degree north of west, and then she went, if you wanted to do it out at the end here, you could say she went 200 due north. Okay, so if we could figure that out geometrically, we just want to figure out how far back to her apartment. Is that making sense, guys? Now, we could figure this out and do a law of cosines question, but we've been doing it as components, okay? So her initial trip was 1,000 cosine of, be careful, 135. You can do 45, but then you got to put this, make it a negative, okay? Okay. What about this little piece of her trip up here, though, straight north? If you drew it separately, it would look like this, right? So it's a 90-degree angle. So if you wanted, you could do 200 cosine of 90, 200 sine of 90. But what should the coordinates be? Yes? Go over nothing but straight up 200. Everybody okay? All right, so if we add those together, we get the components of her resultant, not the magnitude. We have to do some more work. Is it negative 707.1 and 907.1? It's kind of sad, but I think it's the third time today I've done that question. Is that right? Okay. That's her resultant. So this is where she's actually at from home. She's, to go back, if she went back like at a right angle to home, she'd have to go 907.1 down and 707.1 back, but she's going to go straight back to her apartment. So how do we find the magnitude? Yes, magnitude equals Pythagorean theorem. So it's the square root of 707.1 squared and 907.1 squared. You can put the negative in there, but it doesn't matter. I typed it correctly this time without 10 tries. I got 1150 roughly feet from home. Does that make sense, guys? She went 1,000 and then 200 north, but if she goes straight back, she'll be a little bit less. 1150 back. Seems okay? All right, then the trickiness. Okay. They want a quadrant bearing, same as they gave us, so how far north of west, all right? It says how far north of west, quadrant bearing. So I'm going to go down to this problem right here. Okay, and I'm going to do inverse tangent of my components. I'm going to go second tangent, 907.1 divided by 707.70. Oh, I can't type again. Negative 707.1, right? Put the sign in there and everything. You get negative 52 degrees. Is my calculator broken? Yeah, the calculator thinks that we are in quadrant 4, but we're really in quadrant 2. But guess what? What is that angle right there? 52 degrees. It's a vertical angle, right? See what I'm talking about here, guys? So, well, we could add 180 and get 128. Then we'd still have to find the rest of the way to 180, so we'd end up getting 52. Okay. So it's a 52-degree angle north of west. Okay. There is not a question like that on the quiz tomorrow. Next quiz, yes. This quiz, no. Okay. That being said, there is a question that has two vectors you have to add. And I have an example of that. But first I'm going to do number 5 for Emerald, okay? We ready? I'm going to do this one the same way. Airplane 500 miles an hour due north. What's that look like, guys? Can you give me the vector? Straight up north, so its components are over 0, up 500, or you could do 500 cosine of 90, 500 sine of 90, right? Yeah, I know my pictures are awful. Okay. Yes. 500 miles an hour straight off the face of the earth. Okay. If a 50-mile-an-hour wind is blowing, okay, at a bearing of 270, first of all, a bearing means off of what? Off of due north in a clockwise direction. 270 is this line over here somewhere. Now we got to decide at or from. From means we draw Mr. Wind out here and he blows us the other way. But at means we are actually going out that way, okay? I know. Mr. Wind, if we drew Mr. Wind, he'd be blowing from that bearing and he would actually blow us to the east, okay? But at this means at a bearing, so the wind is blowing us at that direction. I don't know how else to explain it. At is away from the north-south line. I will tell you, if I leave it on the next quiz that has a question like this, I drew the picture for you. You have to put all the angles in and everything and the numbers, but just to make sure that you didn't get confused about the at or from, I put it on there. All right, that's not on this quiz at all, though. All right, and that's 50 miles per hour. Can you give me that vector, guys, without me doing any crazy business? Negative 50, 0, would that work? So when we add those two together, we get which is, if we moved this up here and did this, we'd have this, okay? It went 50 that way, so this is where we actually wound up. All right, how do we find out how fast it's helping us go or slowing us down? Pythagorean theorem. Did that wind help us much? I'm guessing not too much. Anybody get 502.5? Why didn't it help us? It's not a tailwind, it's not a headwind, so it slowed us down. It's like totally at a crosswind, right? It's blowing at a 90-degree angle to the plane, so it didn't help much at all. But I'm thinking it did blow it off course, yes? Okay, our resultant vector is here in quadrant 2, negative 50 and 500 again. So when we do an inverse tangent of 500 over negative 50, what do we get? 80, negative 84 degrees? Okay, is the calculator confused again? It is, but it is the same angle as inside our triangle here, 84 degrees, right? That picture is so bad. Okay, the 84 is here, negative 84, so it's also in here. But we need a bearing. Because it asks this as a bearing, so we're getting, but look, guys, it's not that bad. Look, 90, 90, 90, and 84. Off of north, we went 270 plus 84 more would be 354 degrees bearing. Okay, the plane was trying to fly due north, so it shoved it off course 6 degrees, yes? Okay, 6 degrees off course, if that helps you think of it. Yes. It is in this triangle, yes. But that's still all the way around to there. You okay? All right, again, that's not on the quiz. I want to go to the green sheet for a couple minutes because on the back of the green sheet, it says some words. Some words. Okay. It's a little note to you from Ms. Hoffbauer. Dear favorite class ever of pre-calculus, there are conics on tomorrow's quiz. You may use the pink sheet, but you have to know everything from the last quiz, okay? There's maybe a little graphing. Actually, I don't think you have to draw an ellipse, a hyperbola, or a parabola. The only graphing on the quiz is draw a parametric, like given 3t plus x equals 3t plus 5, y equals t squared, where the t value goes from -3 to 3. We can do one of those if you need me to, okay? Mostly there's some multiple choice questions about conics, but need to know how to find eccentricity, and you need to know how to complete the square correctly. Didn't go well for some of you last quiz. And, you know, it's not like I've ever done one on the board where you had to complete the square, only about 3.875 million of them, right? So I will do more, but I'm just telling you, please get this down. You got to be able to complete the square. Okay. Eccentricity, circle 0, parabola 1. That's not on your pink sheet, but this is. It says on the back of the pink sheet, ellipse, eccentricity is C over A. Does it also say it has to be less than 1? Okay, and a hyperbola C over A, but greater than 1? Okay, because there could be a question on the quiz where it says the eccentricity of a conic is 2.3. What kind of conic does it have to be? Okay, that'd be a really easy question, right? For Curtin to get wrong. Okay. Also on the quiz are parametrics, which we have just talked about. But you have to be able to eliminate t, and you have to be able to sketch. So if you want me to go back and do some of those, I certainly can. Including one that has a sine and cosine. And then there's a vector question. Okay, we got 14 minutes left. This is what the vector question looks like, one of them, the hard one. The easy one just says, it's a 30-degree angle and you're going 70 miles an hour, what's the vertical component? Or what's the horizontal component? That's it, okay? But this one is on there, and it's sketched like this for you, okay? So, and it asks all these kind of questions, so therefore you need to do it by components because that's the way it's asked, okay? All right. Damon, whose name changes to Donald halfway through the question. With time running, guess what it might be on the actual quiz? All right. With time running out in a game, Damon runs with the football at a speed of 8 feet per second. So he's running 8 feet per second along the ground, and then he throws the ball at 17 feet per second. So what is the velocity of the ball after he throws it if this is a 70-degree angle with the horizontal? Okay? No, you're going to do it by components because I'm mean and horrible and you have to do it this way. Okay, so this one, yes, we could just go over 8 up 0, or you could do 8 cosine of 0, 8 sine of 0, okay? Components of B, how are we going to do that? And you could literally write that in the blanks here. If I don't care. Or you can type it in and get decimals. Got it, guys? I'm easy either way. You know that about me, right? 5.8 and 17 sine of 70. I got 16 roughly. Yes? Okay. So what is the component form of the resultant? What are we doing there? Adding. So 13.8 and 16. We good so far? Resultant speed. How do you find that, guys? Magnitude, which is Pythagorean theorem. I got 21.1. Anybody? Okay, so because he was running when he threw the ball, it went a little faster than the 17 he threw it at. It went 21 because of the added speed that he was running. Okay. Angle with the horizontal. That's just inverse tangent, and there's no craziness. You just do y divided by x. It's not a bearing question. I got 49.2 degrees. Yes? Okay. Do you understand? I'm not asking a bearing question on tomorrow's quiz, okay? All right. Now, some of the things that I just went over that people looked fuzzy on. Parametric, eliminating t. This is page 469. I'm just picking a random problem. I don't know which ones are assigned. Were the odds assigned? Parametrics, 7 through 15 odd and 19 through 25 odd. Okay, so I won't pick that one. I'll pick this one. How are we going to do number 23? It is magic. Do you remember what magic we used to eliminate the t on that? Or the theta in this case? Yes, we did x over 5 equals cosine of theta, and y over 6 equals sine of theta, and then we magically decided to do what? Square them together, square each one, so that we could add, and instead of cosine squared plus sine squared on this side, that was a 1, and we wound up with x squared over 25 and y squared over 36. Remember that? Now, what else could you have done? If you had graphed it literally on your calculator and figured out an appropriate window and everything, you might have seen that it was an ellipse and figured out how to write the equation, but this is not hard, yes? Okay. What about eliminate t on one like this? What was assigned on 9 through 15, guys? Does anybody know which one? 7 through 15 odd were assigned? Okay, so let's do 13. How could we eliminate t on that one? Okay, so we could make x plus 4 equals negative t. We divide everything by -1. We get a negative x minus 4 equals t. Then what? We're going to put all that into this one. So y equals 3 times that ugliness squared. And if it's not multiple choice, I will accept any version where there's not a t anymore, okay? I don't care how you... If it is multiple choice, you got to fiddle around until this is equivalent to something that's on your paper, right? You got the eliminate the t thing now? What about graphing one of these? It will give it to you. Yep. Okay. No, there's one on there where you, yes, but it's given. So like if this exact question, number 2, was on the quiz tomorrow, it gives you a little chart and it says TXY and it's blank because you have to know to do -4, -3. It's written here, but -2, -1, 0, 1, 2, 3, 4. It's probably not that many points on the quiz tomorrow because you might be there all day. To find x, you square them and divide by 2. I'm making up things as I go here. Square it, divide by 2. And then to find y, it says multiply by -4, right? 16, 12, help me. 8, 4, 0, -4, -8, etc. And then you plot those points. Do you remember what else you have to do though? If you go over 8 and up 16 and the next one is over 4.5 and up 12, and I'm thinking it's going to go like this somehow, you're going to be doing this too, remember? Okay? But can I put it in my calculator to check? I can even put it in the calculator and then look at the table to find the values, okay? One of those. All right. I feel like the thing I didn't review the most today was the conic stuff. Is there something off the green sheet you want me to do one of those? Like a completing the square? How about this number 4 right here? You would have 9x squared. There's no other x, right? If you move the 25y squared and the 100y over to that side and the 325 to the other side, you get that. Then what do we have to do? We don't have to complete the square with the x, but to complete the square with the y, we have to take out a -25. So we get what? Keep guessing. Are we okay? We divided both of those by -25. Okay, 9x squared minus 25. Completing the square here gives me half of this is plus 2. Squaring that is 4. Morgan, 1 squared is? Yes. I was like, really? The whole class has this problem? Yes, guys, 1 squared is 1. Be careful. But 2 squared is 4. What goes to the other side, though? This is the part that blows my mind that you're still not getting this. -25 times 4 goes over here. So then we have 225. We divide everything by 225. So that we have x squared over 25 minus y plus 2 squared over 9 equals 1. Okay, guys, huge issue. For eccentricity, C is defined differently for an ellipse and a parabola, hyperbola. A is also defined differently for an ellipse than a hyperbola. This is a what? This is a hyperbola. How do you find C on a hyperbola? Yes, you add. So you get square root of 34. Which one is A? The positive one, but this is A squared, right? So A is 5. So the eccentricity here is square root of 34 over 5. Now, if it's an ellipse, start over because you find C by subtracting, not adding. And A is always the bigger of the two, not necessarily the positive one because they're both positive anyway. Better? Okay. Anything else you want me to do? Only, but they're both positive in theory. It's under the positive term, yes. Because it's got a minus in here? Yep. No. If it's a minus, it's always. If it's a plus, it's an ellipse. Yes. Good question. Okay. Quiz tomorrow. Oh, I know I was going to tell you. If you want more practice on any of that, green sheet has answers on the back, but I made another worksheet that's like the green sheet and has a little more vector practice. Worked out answers on the back. It's up here. I ran 50 of them, and so far I think 3 have been taken. So humor me, take a worksheet.